Welcome to our uh, current version of the ID 110 distance learning. Um, Thanks for your patience on all the technology. By the way, we are challenged a little bit here with having a little bit of slower internet than we liked. That seems to be a problem that's being worked on now. So if we have a technical glitch, I'll try to work through it as best as we can. All right, so tonight we're talking about linear perspectives. Here are some of the terminology and vocabulary that we'll be talking about, and there's some things that are probably pretty helpful in the reading. I would suggest that if any of this sounds difficult or you need a second run at it, do please read the text. This information that I base the lecture on will be mostly set around the information found in the textbook. So illustrations and content alike. Okay, so we're starting the topic of linear perspectives with the idea that the perspectives are set up for um, a viewing with a single fixed position and a one eye kind of view. And what that means is that our natural sight that includes binocular vision for most of us who have, fully operable vision, it means that we see things differently than we might be seeing them in these perspectives. And even though the goal of perspectives is to provide as experiential a view as we can of the object or the building or the interiors we're working on, certain optical illusions are created by the idea that we can only see things through one eye. And I'm going to tell you that I had a classmate in college who was a really nice guy, and he had an accident a number of years before he started college, where he was working at a construction site, and he fell off a ladder and hit his head, and he lost vision in one eye. And his eye was healthy, but it damaged the nerve in some way. And so he could not, he could only see with the one eye. And what we learn about human vision is that we get the benefit of depth perception from, having binocular vision. And so some of the challenges that go with perspectives is that we don't get the full sense of binocular vision, but we do get pretty close. So as I mentioned, and as should be known, is that perspectives employ, the tools that are required for 3D imaging. And these degrees of image are important in that they provide the person viewing it with some context that is much more realistic than might otherwise be observed. So as we go back and think about our multi-view drawings, they're just two-dimensional information, and so they're not very good at telling a combined story. So as we come to the 3D drawings and we're using perspectives, we have an opportunity to show much more about our designs and about the ideas that we had for them. So as a result, there's certain ideas or concepts that are provided in perspective drawings. And one of the ideas is that the things that are close to us tend to be larger, and the things further apart tend to be smaller. And so that is not a simple thing to understand, and not necessarily intuitive to everyone's thinking. I'm going to do a little something I wanted to do earlier and I forgot to. I'm going to depart from the PowerPoint for just a moment, and I'm going to bring up a little video because I think it speaks to the idea that um, you know, Og didn't come out of the cave, scratch himself, and start drawing perspective drawings. It wasn't until, you know, basically the Renaissance where they learned how to do this. And I have a quick little historical video that I think might be helpful to watch. So I'm going to depart from our context here, and we'll come back to it in just a minute. Oop. There we go.
John, I'm not sure we can hear it.
Yeah, are we supposed to be able to hear it? Because it's very, very, very faint.
Okay, so that little, if it didn't come across quite right, I apologize for any technical things that may have happened there. But what I wanted to share with you is that the topic, this topic that we've been introducing here, is one that has kind of baffled people for a really long time. Oh, sorry. I'm gonna turn this off here just a second. Just, just sorry. Just a second here. Sorry about that. Okay, let's close our guys right here. Sorry about that. Okay, we'll bring that back up in a second here. Too many things going at one time. All right. So as we flip the current slide, there we go. Okay, so here's the thing. Basically, in the old days, they made people look small, and they said that's in perspective. Well, that's not exactly correct, and there are some very strong rules for how these things work. I will say that the process of developing this was pretty ingenious. If you look at the video and watch it again, you'll see that it's not intuitive, all the little steps that Brunelleschi applied to that process. So as we move forward, there are these rules, and one of the rules, as we start to look at the process of building perspectives, is that we're working with projections or projected lines and projection points. And what ends up happening is that the way we view things includes a whole variety of these projection lines that define the object by either it coming towards us or receding away from us. And so these lines are either expanding out or converging, and they converge typically at the vanishing points. And so what ends up happening is that, every time we look at something, and we change our position, the perspective changes. And so we take into consideration that how we set up a perspective is intended to provide the viewer with what we believe is the most important parts of the design for them to see. It shouldn't be overly complicated to think about it to consider that when you think about it. Your ideas need to be conveyed to a person who may be a lay person or someone who doesn't understand the complexities of a multi-view drawing and how to put them together in a variety of different ways. So these projected lines, they really create what they're referencing as sight lines. And sight lines generally are, like I said, going to they're receding, or they're going to the one eye of the viewer, and they are also projecting to the vanishing points to create the correct alignment of all the planes and lines. Generally speaking, perspectives are experiential, and I'm gonna say at this point that there is a measure of art in these drawings. One of the things that happens is that we can edit out information that and add information to a perspective drawing to suit our design purposes. It's very dangerous to do that with multi-view drawings, because the multi-view drawings are intended to provide, just these singular blocks or these singular elements, the floor plan being different than the section, being different than the elevations, and those need to be put together in such a way as they can be delineated in an organized way, but also constructed. So construction documents are principally put together with multi-view drawings. The Paraline drawings are or something we talked about really in the beginning of the semester, and we experimented a little bit with them when we looked at those volume studies for the isometric, the plan oblique, and the elevation oblique drawings. These drawings, these Paraline drawings, are really used to organize and connect the multi-view drawings together in a three-dimensional image. Perspective drawings are intended for the viewer. They're intended to take someone who may not understand all the technical aspects of the multi-view drawings and give them a sense of what is it going to feel like, what's it going to look like, and so they're very successful that way, and they're used primarily as I'll say a sales tool, or a tool that is used to bring people along and persuade them that your design is appropriate and effective. All right, so here's some of our words that we will be looking at. I don't want to get too deep into them because, again, they're in the textbook, but we've already introduced the idea of what the picture plane is about. It's basically that framework that you're looking through to see the object. The center line of access, or center line of vision, is really the sight line of the observer. So if I'm standing and I'm a kind of short guy, and my eye line is at 5 foot 5'5", say, then that is the sight line of the observer. This point is not just the elevated height, but also how far away they are and at what angle they are. So it's a way of describing the position that the viewer is in. The horizon line, we know what that is. That basically is that optical illusion that happens when our eye can no longer discern the detail. We have a generally where the sky meets the earth is the simplest to think of that. If you're out on the ocean, it's kind of where that long horizon line where the sun sets, and where our view of the things that are on, I'll say, the earth and our planet here are no longer are separated from those things represented by sky. So as a result, there is a center of vision. That is where the horizon line intersects the axis of vision. By the way, that's a universal kind of thing that you'll hear me mention it multiple times, especially as we move forward, that your eye line or your eye placement is, and generally we're standing and walking around, that is where the horizon line is going to occur. It's one of those unique aspects of our vision is in that when we are standing on a step ladder, maybe 6-7 feet off the ground, the horizon line still meets that center line of vision. And so, and conversely, if we happen to be, laying on the carpet or laying down on the floor somewhere, the horizon line, even though we're very close to the floor, is right there with us at eye line also. So it's good to understand that wherever we view an object, we're going to set our vision line at that point, and that's going to help us with the horizon line. The ground plane is just a three-dimensional aspect of the thing we're putting our object on. And then the ground line represents those lines that where they intersect the picture plane and the ground plane. Okay, so these are all really technical little words of that probably are good for sharing at a cocktail party, or maybe to impress your friends, but otherwise we're not going to spend too much time. We'll use them in a little bit more detail, but they are in the textbook and worth taking another look at. All right, so there's kind of an alignment. You can see our little figure here. This is supposed to be Filippo Brunelleschi from the textbook, and you could see how all those parts and pieces kind of come together, and you could kind of see all those descriptions that I was giving you in that earlier listing of vocabulary. You can kind of get a sense for how it all works. All right, so one of the things that we want to make sure that we there's some rules, and this is one of the aspects, is that, you know, there's projections that we make from that point at any point on the object is where it intersects the picture plane. So that is important, because we want the picture plane to always be square to our vision, or when I say that, meaning basically our view is being applied at 90 degrees to the picture plane. And so, and that will always occur, as I mentioned, where the horizon line occurs. So let's talk a little bit about what happens with the conventions of human vision. We don't have infinite vision. There's certain physiological limitations that we have. We're generally dealing with a cone of vision, and that cone is set at about 60 degrees, 30 degrees around a center line of vision. And because it's a cone, it's not square. Our drawings will be square, but the cone of vision is like a circular line of sight, or a circular area of view of 60 that is projected from the eye at 60%. So a small cone of vision would be that is less than or that 30%. A larger view would be greater than 60%. The largest view would be 90, and that falls outside our peripheral vision. We're starting to move into the area of peripheral vision, and not one that's altogether that noticeable. So if you ever want to have fun with this, you know, get yourself a fisheye lens for a camera and look at that. You can see the kinds of distortion that happen as we look through cones of vision that are wider than those that nature provides us in our own eye. Okay, and so that idea of that cone is represented there in this illustration. And so it doesn't necessarily give us this really wide view of things. And it's okay, because as we start thinking about perspectives, we're going to start imparting upon them the idea of composition. And we'll talk about this much more next week, in that a fair amount of the work that we'll be doing with perspectives, and that you'll always be doing with perspectives, is that they are almost more art than they are science. And so as a result, we can exercise a little bit or significantly more artistic license with them, as long as we're following the rules of perspective, because once we violate those rules of perspective, then the viewer starts to critically break down the drawing and start to have trouble understanding it. So as a result, you know, these conventions of the human vision are important to keep in mind, because as you look at artwork, your eye will move around a painting. It isn't necessarily fixed on just one aspect of the painting. And that's true with our perspective drawings also. Okay, so wow, we've got lots of lines and so on. So let's start with the idea that when we were working on those multi-view drawings, we were dealing primarily with vertical and horizontal lines. Okay, so that we had 2 dimensions to work with. We now have 3 dimensions to work with, and the things that occur, as you can see in the illustration on the left side of the slide, that as we start to employ these axes, the vertical and 2 horizontal axes, the vertical will always stay pretty much vertical. But the horizontal lines need to find a way of adjusting their placement and their projections, and that's done at the vanishing points. So we'll see this in much more detail in the assignment that we're going to be doing later in this class. So what I wanted you to do is understand the basics as pertains to vanishing points and the lines that are projecting to them. All right, so there are some pictorial effects that happen with perspective, and it's not difficult to think about that vision or that view of the train tracks, that you're standing on the tracks and you're watching them go straight to the horizon, and there's an optical illusion that happens where the lines are getting closer to each other. The distance between them is diminishing, and they're actually contracting in view. But in honesty, they're not. The train is still going to ride those tracks. They are going to the horizon on that train track with the train on it, and it doesn't converge. But optically, they do. And so that's one of the things that happen with these types of drawings, that they have to employ the same natural distortion, the same natural effects of perspective that we see in our real life. So as a result, these pictorial effects, we start to see converging and compressing of the lines as they get further away from the viewer, and that distortion happens around us in all the things that we're looking at out in the real world, but we just take it for granted because our brains have accepted it and they understand that that's the kind of world we live in, and it makes accommodation for it. So as a result, there's this diminution of the of size as we converge those sight lines to their vanishing points. And you can see that in some of the illustrations here. Some of the elements get smaller and closer together. Some of their juxtapositioning changes, and some of the elements change their shape as they move closer to the horizon line. So all these things are part of the optical illusion or optical distortion that happens with perspectives. Now, some of you might be thinking, gee, that seems harder to do than all the great scale drawings we were doing with the plans and elevations and all that. That is true, but we can't represent things realistically without employing all these elements of distortion. And because that's the kind of view that we look through our eyes and we see. So not only are we affected by the elements as they are presented from our view angle, but also our elevation, how high up we are. And we'll see some of this in our assignment a little bit later in this class meeting. And what that means is that it's not hard to understand that if you're flying in on an airplane and you look down, your perspective's going to be substantially different of the city or the environment than it would be at ground level. And so there's a lot of changes that occur in perspective, and they have to do with how we place that station point, whether it's low, medium, or high. And so be conscious of that and how things work with overlapping cues and other placement challenges of perspective. And that's what I have to share.